another one similar to this. So you have here, example number 4. I have 8x to the 2/5 equals to 24. Actually, minus 24 equals 0. So once again, is my equation in ordinary form? Not yet, because besides the rational power, I have a minus 24 attached to that term, and then the rational power itself, it comes with a coefficient 8, which is not a 1. So I don't want that. I want just one single rational power only. And so to bring the equation back to the ordinary form, I need to add 24 to both sides. And that gives me 8x to the 2/5 equals 24. And now one more step to bring that to the ordinary form. Dividing 8 from both sides. And that leaves me x to the 2/5 power equals 3. Okay. And now my answer, once again, to come up with my answer, x equals to 3 to the 5/2 power. And here, if you look back into the ordinary form, my numerator of the rational exponents is an even number. So in my final answer, I need to do plus and minus. Now in this problem here, I decided, let's say we're going to go ahead and stop it right here, for the reason being, we don't know how to evaluate further 3 raised to the 5/2 power. I mean 3 raised to the 5/2 power is just simply square root of 3, and then we raise that to the 5th, but back to the origin here, square root of 3, we don't know how to handle that besides the calculator. So let's just for now leave the answer like this. Plus and minus 3 raised to the 5/2 power. That's how we're done with this problem. Okay, and that was example number 4. So example number 5, things are growing a little more challenging now. So this time, let me write in the title of the problem: solve for x. So we've been solving for x, but here the reason here is x is not the only expression here. X is part of the expression. So my equation here, and this type of example has never been mentioned in class. We never have enough time to mention this in class. So here, pay attention to this carefully. I have an x minus 4, 1 expressions, and being raised to the 2/3 power, and all that here equals to 16. Okay, so now, don't get yourself stressed out with this sort of new type of equation, but here still, we're ending up with a rational exponent, aren't we? We're still having a rational exponent. The x minus 4 in here, at first, do not let it scare you away with that. Just think of that, all that I've explained in class. What I care here is I have 1 expression being raised to a rational exponent and equals to a number on the right hand side. So that means my equation right now, it is in the ordinary form of 1 expression raised to a rational power and equals to a number k on the other hand side. So I still have that here in this equation. So it is still in ordinary form. So now to solve for this, all you have to do is, once again, the whole point is rewrite that expression x minus 4 without the rational power, and then make it equals to the 16 on the right hand side. You're going to now raise that to the 3/2 power, which is the reciprocal of the 2/3. And now, do not forget, you need to do plus and minus. What's the reason being for that? The starting numerator, the numerator in the starting rational exponents was an even number. So now I need to do a plus and minus here. So now 16 to the 2/3 to the 3/2 power, can we actually evaluate that number itself? Yes, we can. Now square root of 16 is a 4, and 4 raised to the 3rd power is a 64. So actually I have x minus 4. I come up to myself with an expression x minus 4 equals plus and minus 64. Am I done? No. You see, if you look at the equation here, we want to solve all the way through until we find out what the value of x is. Here we have only found an answer for x minus 4. We know that x minus 4 equals to either plus 64 or minus 64. But we don't know what x is, so we need to go 1 step further to solve for it. This plus and minus sign, once again, it means x minus 4 on one hand equals positive 64, and x minus 4 on the other hand equals negative 64. So now solving for x, just simply adding 4 to my first equation, and that gives me x equals 68. That's my first solution. Now, for the other equations, adding 4, that gives me x equals negative 60. And there it goes, my other solution. So now I have found the two final answers to my example number 5. And keep in mind, this equation here, the highlighted point here, is even though it looked a little bit unusual, however, it's still in the ordinary form because I have one expression, x minus 4, so treat that all as one expression, x. And we raise that to a rational exponent's power. And then it all equals to a number on the other side. And then let's try one more example with all this rational exponent business here. So my example number 6. Okay, what I'm having here. Once again, let me write down the title. We want to solve all the way to the end for x. Okay, and my equation appears to be x squared minus x minus 4, with all quantity, all expressions there, raised to the 3/4 power, and minus 2 equals 6. So now, once again, do not let the complicated expressions scare you away. It's close. This equation here is close to being in the ordinary form. I still have one expression, one whole expression here. I still have that one whole expression raised to a power, a rational power. The only thing I need to worry about is that minus 2 right here. It's not part of the ordinary form, so I need to rearrange that 2 by adding it to both sides of the equation and bring that to the other side. So that leaves me x squared minus x minus 4 all raised to the 3/4 power equals 8. Now my final equation here so far is in ordinary form once again. I have one expression. See, I don't really have to, at this point, I don't really have to pay attention to whatever the part inside of the expression here is going to be. All I care is it's one expression being raised to a rational exponent and equals number 8 on the right hand side. And so now, to solve for it, I'm going to just simply rewrite, copy down the expressions. X squared minus 4, x squared minus x minus 4 without the rational power, and equals, now the number on the other hand side, 8 raised to the 4/3 power. And once again, what I just did, I simply take the reciprocal of that power 3/4 and that turn it into a 4/3. And do I need to add a plus and minus here? No, I don't need that because, once again, my starting rational exponent right here, the power, the numerator for it was an odd number. So here all I have to do is just ignore the plus and minus. So now we can actually evaluate for 8 to the 4/3 power. That would be cube root of 8 is 2, and to the 4th power, so that makes it 60. So my equation turns out to be x squared minus x minus 4 equals 60. Now you are back into something you are so familiar with, a quadratic equation. So just simply subtract 16 from both sides, and that leaves me x squared minus x minus 20 equals 0. And once again, at this point here, I see to myself that factoring is my fastest access here. I can do x minus 5, x plus 4. And those are my two answers. Those are my two factors. So now to solve this equation all the way for x. X minus 5, I'm setting that equals 0. X plus 4, I'm setting that equals 0. Here I have adding 5 from both sides. That gives me x equals 5. Subtracting 4 from both sides, that gives me x equals negative 4. So now my two answers I have found is x equals 5 and x equals negative 4. And that is how I've solved for my example number 6.